Assalamualaikum. Hi, and a very good morning to everyone. So, today we will have a lecture on recombinant vaccines. I believe all of you are aware now that vaccines is a hot topic these days, especially due to the emergence of COVID-19 pandemic, which necessitate the emergency need of vaccines to stop the spread of the virus. But today, we will learn a specific scope of vaccine, which is recombinant vaccines, that is generally produced through recombinant DNA technology. This involves inserting the DNA that encodes an antigen, such as bacterial or virus surface proteins, that can stimulate an immune response. In this lecture, the type of recombinant vaccines, its concept in immunization, how it can be produced, and how vaccine formulation can further enhance the immunogenicity of the recombinant vaccine antigens will be discussed. Okay, before we go any further, let us recap back on our immuno understandings on what is vaccines. In general point of view, vaccination is a simple, safe, and effective way of protecting people against harmful disease. It uses your body natural defense to build resistance to specific infections and makes your immune system stronger. And vaccines typically contains an agent that resembles a disease-causing microorganisms, and they are mainly made from the weakened or killed forms of the microbes or the microorganisms from its toxins or from one of its surface proteins. When we talk about surface proteins, this is what we consider as part of the subunit vaccines. So here are some examples of vaccines that are currently used in clinical setting. Most of the traditional vaccines are made of from the whole microorganisms. As I mentioned earlier, either they are being weakened or inactivated. And usually, the microorganism is weakened or attenuated by using a strong heat or chemical, such as formalin. And more recently, we do have a recombinant vaccines that are used clinically. For example, here like the Hep B vaccines and also the pneumococcal vaccines. Just a brief idea on the mechanism of action of a vaccine. So basically, vaccines help develop immunity by imitating an infection. This type of infection, however, almost never cause the illness like the pathogens, but it does cause the immune response to produce T lymphocytes and also the antibodies. Once the imitation infection goes away, the body is left with a supply of memory T lymphocytes as well as the B lymphocytes, which is in the form of the antibodies that will remember how to fight the disease in the future. So, when the actual disease, germs, or pathogens ever attack the body, the antibodies will return and destroy them due to the induction of memory immune response. So in general, this is how vaccines works by stimulating our own body immune response. So what properties make a good vaccines? Of course, the vaccines need to be able to stimulate the appropriate immune response against the particular pathogens. To stimulate the immune response means that it should also be able to confer protective effects against the pathogens. And this how in these days we measure it by the vaccine efficacy percentage and also the vaccine efficiency or the potency. Like the COVID-19 from the Pfizer is 95% effective to confer the protection. And also the vaccines need to produce a long-term protections, mean it should be available to ensure that our immunes can develop memory as long as possible to ensure that we can achieve the long-term protections. That's why you can see some vaccines they require 2 dose, 3 dose to ensure that we achieve the maximum protective efficacy and also the maximal duration of the period of time that the vaccine can still confer its protection. And of course, vaccines need to be safe and also stable. So that's why some of the vaccines need to be stored in a cold chain environment to ensure its stability so that when it's injected to the particular individual, it still remain effective and efficacious. And importantly, vaccine need to be not too expensive as vaccine is meant for prevention and prevention means that we need to ensure that it can be distributed globally and everyone has access to it, especially to the third world country. So traditional vaccines, as I mentioned earlier, most of the vaccine formulation that we had, basically they are based from the whole microorganisms, either they are being attenuated or killed, and they are producing from the cell culture where we grow the virus and we make them to be inactivated or attenuated. And one of the reasons for the safety concern associated with the use of whole microorganism as vaccine antigens is that especially for a virus, because we know that virus is causing the illness by attacking the genomic materials, even though they are being weakened or inactivated, there are still potential that they can revert back to its virulent state. So it's really important this attenuation process need to be carefully being done to ensure that the organisms lost the ability to evoke the immune response, to evoke the unnecessary immune response. So we need to be sure that they are really being inactivated or attenuated when doing so. So these are the some of the drawbacks that associated with the traditional vaccines that utilizing the whole microorganism as vaccine antigens, which is it's not possible to develop vaccines for the organisms not grown in culture. The yield of vaccine is very low, so somehow it can be expensive. and also the cell cultures are costly to maintain. This is the one that I mentioned earlier, where there is a danger of non-virulent organisms getting converted to virulent ones. Vaccination by such organism may cause the disease itself if they can revert back to its virulent state. And no one size fits all, which means that not all traditional vaccine formulations is suitable to be developed against all of the disease. For example, we still have no vaccines against AIDS, for example. So these are currently one of the some of the advancement made in vaccine developments, where instead of we have the use of whole microorganisms, we have only several parts of the microorganisms that can be utilized to be developed into vaccine antigens, like recombinant viral vectors, recombinant bacterial vectors, and the use of DNA, recombinant subunits, or even a synthetic peptides, which is a specific peptides that is isolated from the proteins, from the antigenic protein. So basically, these are all we can consider as a subunit vaccines, which includes only parts of the virus or bacteria instead of the whole microorganisms. And these vaccines contain only the essential antigens, which means that the side effects are less common. And most of these subunit vaccines, they are made from DNA recombinant technology. Even though the approach is overlapping here, for example, like recombinant viral, DNA, recombinant subunits, but they are all made from similar approach, which is the DNA recombinant technology. And in general, we can divide the recombinant vaccines into two, which is the DNA or RNA vaccines or the recombinant protein vaccines.